All right, this is going to be a quick video on limits using your TI-89 calculator. Okay, so I'm going to do some simple limits first. So let's do the limit as x approaches 3 of x squared plus 7. Now I know that this is simple and you can plug that in using substitution and you get a number, and you can do that in your head. But this is how you would do this on your calculator. You have to use the calculus menu, which is F3, and you scroll down to number 3, which is limit. Now, you plug in your function here, which is x squared plus 7. Okay? And you put a comma here because you have to tell the calculator what the variable is. And in this case is x, comma, and then you type in what x is approaching after the comma. So I'm going to put 3, and then you close parentheses and you press enter, and the calculator tells you 16 because we knew when we pressed in or put in by substitution, direct substitution, we get 9 plus 7, which is 16. What I love about this calculator is that it lets you see, using the pretty print type, whether you are looking indeed at the same exact limit, and you are there. So we know that's 16. Okay, now let's say we wanted to find the limit of a function. X approaches, let's say 0 from the left side, because sometimes we want to know what the derivative is, or I mean the limit of something is from the left or the right side. Okay, so let's try, I don't know, 1 over x plus 1. And we want to find out what the limit is from the left side of 0. Now, of course, again, we could do this using direct substitution because that's not a problem, but I wanted to start off basic. Okay, so how do we do our limit? We go to F3, scroll down to number 3, press enter, and then we go 1 divided by parentheses x plus 1, close, comma, you tell it what the variable is, comma, what x is approaching. Now, x is approaching 0, comma. Now, this calculator is programmed so that when you want to know what the limit is from the left side, you don't press the negative key, you say -1. -1 is what the program understands to be from the left side. Okay, so if I press enter, we see that if you plug in 0, and we knew this to be the case, it would be 1 over 0 plus 1, which is 1. But if you look at the pretty print language here, you see that the limit as x approaches 0 from the left side, there it is equal to 1. So we'll put that here. So what happens if we want to know from the positive side? So what's the only difference? Yep, you got it. You take away the negative sign and you press a 1. And there it is, the limit as x approaches 0 from the positive side of 1 over x plus 1 is 1. Now this gets more interesting when you have a discontinuity at where you're trying to find the limit. Okay, so let's try this one. The limit as x approaches -1 from the left side of 1 over x plus 1. Now I chose that obviously because this is a vertical asymptote for this function at x equals -1. So let's do that on the calculator from the left side. Let's see if this calculator can handle it. So we're going to go F3, limit of 1 divided by parentheses x plus 1, comma, with respect to x, as x approaches -1 from the negative side. And we're going to put -1. So that means the negative side. And lo and behold, there it is. The calculator says that's -infinity. And if you remember what the curve 1 over 1 plus x looks like, there's a vertical asymptote at x equals -1 and horizontal asymptote. And this is just the 1 over x function shifted to the left by 1. And we sure indeed see that from the left side it goes to -infinity. All right, so let's try it as an exercise from the right side. So what's the only difference that we're going to show in the calculator in this case? Why, yes, you're right. We're going to take away the negative part. because now we're so this is going to read the limit of your function with respect to x as x approaches -1 from the positive side. So as I'm using a +1, and we get infinity. And if you look at our graph, we sure indeed do. Now, I guess the question is the calculator smart enough to know from both sides what's going on? Well, let's see what happens when I take away from the side. Oop. Well, the calculator says it's undefined, which means it does not exist. And we all know that it does not exist since the limit as x approaches -1 from the left side of f of x is not equal to the limit as x approaches -1 from the right side of f of x. And we know that to be the case. But the calculator is going to say, instead of does not exist, it's going to say it's undefined. Okay, so that's how you know that the calculator is telling you that it doesn't exist. All right. Well, I think that's about it on limits on the TI-89. So have a good night.